This is August 2017 Math Geometry Regents question number 29. It says the coordinates of endpoints, this symbol means segment AB are A. It occurs at 2, 3. So right away I'm going to put an X above the 2, a Y above the 3, because I'm actually going to, although it says the use of this axis below is optional, I'm going to use it. I like a very visual learner. So I'm going to go over 2 units along the x-axis, and then I'm going to go up 1, 2, positive 3 units on the y-axis and call that A. It says B is located at 5, negative 1. So once again, I'm going to put X above the 5, which tells me to go 1, 2, 3, 4, 5 units on the x-axis, but negative 1 on the y-axis. So that's point B. And it says that this is a segment. So I'm going to use a straight edge, and I'm actually going to draw that. Here we go. It says to determine the length of segment A prime B prime, the image of segment AB after a dilation of a half centered at the origin. All right, so there's a couple of different ways you can do this. So one way is to start with finding the length of the original segment, and then the dilation means that the figure is going to get bigger, or in this case, because it's multiplied by a number less than 1, it's going to get smaller. So if I form a right triangle here, I can actually say this is 1, 2, 3, 4 units down, 1, 2, 3 units across, and I can use this right triangle, and now I can use the Pythagorean theorem. So using the Pythagorean theorem, I can say that a squared plus b squared equals c squared, where c is always the side across from the right angle, which means that's going to be the length of segment AB. So we're going to use the numbers 4 squared plus 3 squared equals c squared. 4 times 4 is 16. 3 times 3 is 9. That's equal to c squared. 16 plus 9 is 25. And the opposite of squaring is square rooting. So the length, I'm going to change C to segment AB. The length of segment AB is 5, which means the length of segment A prime B prime is going to be half of that. So 5 divided by 2, or you could have said 5 times a half. Either way, you're going to get segment A prime B prime to be 2.5. Now that's one way of doing it. You could have said if we take point A at 2, 3 and we dilate it by a half, that means we're going to multiply each of these numbers by a half. 2 times half of 2 gives us A prime, that would be 1. Half of 3 is going to be 1.5. Then we're going to take 0.5, negative 1. We're going to also multiply both numbers by a half. And then B prime would end up at half of 5 is 2.5, and half of negative 1 is negative a half. So what we can do this time is we can plot these points. So point A is at over 1, up 1.5. That's going to be A prime. And B prime is going to be at 1, 2.5, and then down a half. Oh, this is going to overlap this just a tiny bit. So let me use this straight edge, and then I'll use a highlighter. So I have this straight edge here, and then I'm going to use this highlighter here. Here we go. So this is the segment we're now actually finding the length of. So if we do the same thing and form a right triangle, we're going to go down, that's a half, that's 1.5, and down another half. So the length from here to here is going to be 1.5, and the length from A prime over to B prime this way is going to be a full let's go back here. I'm sorry about that. This is a half. This is 1.5 and another half. So that's going to be 2. Sorry about that. So the length from A prime down to the right angle will be 2. And the length from the right angle over to B prime will be a full box, 1 and then a half. So this will be 1.5. So if we go back and we do the same process, which is the Pythagorean theorem, A is going to be 2 squared plus the distance from the right angle over to B prime is going to be 1.5 squared. That'll be equal to c squared. Well, 2 times 2 is 4, And 1.5 times 1.5 is 2.25. That's equal to c squared. When we add 2.25 plus 4, that gives us 6.25 equals c squared. And the opposite of squaring is square rooting. And the square root of 6.25 is actually 2.5. And that's going to be the length of a prime b prime. And I'll just show you that math right here on the calculator. It is the square root of 6.25, and there's where that 2.5 comes from. So you have a couple of different ways to do this problem. This is 2 of them. All you have to do is make sure that you show the appropriate work for the information that you're trying to show, and you'll receive absolute full credit.